2, 1.
Hit it.
Experience 24 hours of head-to-head AWS sessions from around the world.
Mic check, 1, 2.
Jaws PANKRATION 2021. Up till down.
Hello guys, my name is Dilan Jayasekara, and I'm pretty confident that the name displaying below is not 100% correct due to the long Sri Lankan name culture. So anyways, I'm your next speaker for the JAWS PANKRATION 2021. I'm taking over the next session, and I'll be talking about music analytics and AWS for the next 15 minutes. I won't be going into too much technical into this session because of the time limitations I have. So without further ado, let's jump onto the topic. Music is a universal language. Unlike the native languages we speak, for example, I was born and raised in Sri Lanka, and we speak Sinhalese as our native tongue, and we need translators in order to make someone else understand what I speak. But music, dating back to centuries ago, music has evolved from the Beethoven and Mozart era to rock and roll, heavy metal, and K-pop. Even though sometimes we don't understand a word of what they're saying, we just fall in love with them. This is the power of the global language called music. But we live in 2021. It's music as a service now. I came up with it, but it's a thing. The VHS, DVD, and CD era has gone to dust, and it's all streaming platforms being the giants in the music industry. For example, Spotify will suggest you a few playlists based on your listening history, activity, or behavior. But sometimes I wanted to be the curator myself and take ownership to create my own playlists. The best example I can give it to you is that whenever I'm doing a workout, I need good songs, a good playlist that can be playable for more than 2 hours. But I don't want to listen to the same sort of order of the tracks while I'm working out every day. So my requirement was a mega playlist with more than 1,000 tracks in it, so I can shuffle it and play and enjoy my workout. There are dozens of playlists by Spotify, but I don't always like the songs or playlists Spotify is suggesting me because I feel like it's not within the range of my appetite sometimes. So I wanted to create something, a software, a platform where I wanted to find good music, understand the algorithm, create playlists, and I wanted to automate the whole process so I can just sit back and relax. Moving into the next slide, about the first step to this project and how music as a service converted to music analytics as a service. Coming from a data-oriented environment, I love to see everything as a data point and try to find hidden patterns behind data. With this mindset, I wanted to see what I can achieve and how far I can go with analyzing Spotify data. And the results, the findings at the end, they were just pretty amazing. To showcase this, I started 16 Music Analytics. That's my own venture where I start working with a few local artists and produce music of my own to understand the music streaming, music data, recommending algorithm, and the whole music industry better. All right, so the boring part is almost over now. Now, you know my requirement and the whole story behind 16 Music. So let's jump into the fun part of the presentation where I will walk you guys through the data flow part, the analysis part of the project, and how I leveraged AWS cloud service functionalities. All right, so before moving into the AWS part of this, the cloud infrastructure and the whole automation part of it, let me give you a quick overview of what I tried to do, the data flow of it, and the technology stack behind the project. So let me take your attention to the left-hand side of the screen where I listed out the technology stack I used. And the first one is obviously the Spotify API. And the second one is my favorite programming language called Python. And third one is a proper plan to execute to meet my requirements. And at the same time, the plan I should come up with should allow me some space to grow in the future as well. So that's my technology stack. And on the right-hand side is a quick diagram I made to showcase my thought process behind it. As you can see from the top, we have the Spotify API where I use Python to extract metadata. And the important part where I want you to focus is that the three green boxes called user, artists, and global data music. I would ask you to treat these three as three separate lenses you can use, or three approaches you could take towards your analysis. For example, if we take the first one, the first green box, user, this means you can access your own data and do your analysis from there. Imagine yourself analyzing your historical streaming data and come up with predictions, suggestions, and recommendations for yourself. That's the user bucket. Or you can see what's your most favorite artist is up to and what are his or her top songs right now. And then you can go down to the next branch to get the data and its features and how many bars, beats involved in a particular track, and the length and the confidence level of them, and a few other metrics you can use as your key perform indicators as well. And the last green box is global data. That's one of my favorite, and that's my main topic for the presentation as well. This is where you can search for a genre in a certain country and see what are the top trending playlists in that country. And then you can go inside each playlist and pull each track out of the playlist, and then you can perform the feature extraction and all the analysis from there. So that's pretty much a wrap to this slide. And before moving into the cloud version of this architecture, let me give you a quick grasp of what and how this audio features, results, and audio analysis looks like as a result point of view. So I will take the next slide as an example where I extracted data from my Spotify artist channel. And as you can see here, I've got top 10 tracks for the artist called 16. That's my artist channel in Spotify. And you can see there are 12 different features to each song. So basically, the song you are listening on Spotify right now, obviously it's a song to you, but for a computer or an algorithm or to basically Spotify, it's just a file consists of these 12 data points. To mention a few, we got the first column as danceability. It describes how suitable a track is for dancing based on a combination of music elements, including tempo, rhythm stability, beat strength, and overall regularity. And mode indicates the modality, the major or minor of a track. And the last one, not the last one, the valence, the third last one, is my favorite data point, a measure from 0.0 to 1.0, describing the musical positiveness conveyed by a track. Tracks with high valence sound more positive. For example, happy, cheerful, euphoric sounds more positive, while tracks with low valence sounds more negative. So you can search 16 on Spotify or your favorite streaming music platform and have a look at these tracks, and you can refer back to these data points as well. So moving into the next slide, here we have the high level picture of the data architecture in AWS. So I will start from the bottom, start from the event bridge. The first step is every day at 4 o'clock in the morning, what I do is the event bridge rule is triggered, and then a Lambda function is executed. Then what ends up happening is that the code inside the Lambda function, it reads all the trending workout playlists in Australia using the Spotify API connection, pull out each track out of the playlist, and create a new playlist containing all the tracks inside of it. So we are talking about a playlist that has more than 1,000 tracks in it, sorted by the popularity factor. And purely my goal was to do this every day and update the playlists in my Spotify user account. But at the same time, the rest of the architecture, I wanted to save all these in my S3 data lake and then push them up to Redshift using AWS Glue as the ETL tool. The reason I wanted to do all this was in that way, when I look back on the data retrospectively, I can see how the playlist has changed over time and changes of the position of each song. And also, once I have a couple of years worth of data, I can basically do time series analysis to see if there's any seasonality in popular songs, artists, genres, or things like that. So this is just one example of data extraction in this project. Another thing is that in a separate Lambda function, I extract top 100 streaming songs in Spotify in USA, UK, and Australia. And then it's the same story as before. I can apply descriptive analytics on it or predictive analytics on it. using machine learning models to predict what genre could be in a top 3 position in November 2024 in 2 years of time. So this is why I use the SageMaker part of the SageMaker notebook instance in this AWS architecture to do further data science stuff. And also I use Power BI as a connector to my Redshift data warehouse, so I can look at the movements in my playlist easily. I've created an app on Power BI service, so I can easily log into it using my mobile as well, but you can directly connect this to Amazon QuickSight as well. So like that, there are nearly more than 100 use cases that I can name individually. But today my focus is to talk about the connection between the Spotify and Lambda only the Spotify API and the analyzed data part. So then I'll move into the next slide where I will give you the opportunity to experience the playlist automation by yourself. What you can do is, if you have Spotify on your computer or your mobile, you can search for Japan AWS-2021, and then you will see a public playlist called Japan AWS 2021 16. So if you can click on that playlist, and also I have opened that playlist in my other tab, if you can see it, and I will just refresh it and I'll show it to you guys that I created this playlist, but it's empty at the moment. So what I'm going to do is that I'm going to open my Spotify account, and from the Lambda function, I'm going to trigger the function in it. But I must apologize that I won't be able to share my screen on the console because of privacy concerns, and thanks for understanding. So then what I'll be doing is, I will give you guys like a few seconds if you can open your Spotify and find this playlist. This is a public playlist, so I think you won't get any difficulties finding it. So let me execute the Lambda function in my second screen. While I do that, I will refresh this again just to show you guys that there are no songs in it at the moment. Yeah, there's none. So then what I do is that I execute the Lambda function. And now when I'm refreshing it, you can see that there are 23 songs now. And I'm going to keep refresh, and then I'm going to show it to you guys. Now it's 47. And if you have your Spotify open right now, the playlist, then you will see real time all these tracks are getting added. 94 songs. And if I scroll down, you will get the date added could be 6 seconds ago, 4 seconds ago. And if I refresh this again, yeah, 149. So this whole process only takes not more than 2 minutes, and there's 1,300 tracks will be created inside this playlist. So this is just, as I said earlier, this is just one use case that I do just to update everything. But at the same time, I use that CSV file with all the 12 data points. In that way, I can see how the data points changes for the number one position of top 10 tracks in Australia or UK or USA, things like that. So in that way, I can see what are the genres, is there any seasonality, or for example, would or rock music would be in the top 3 categories in a year of time. So things like that. So that's why I'm using the SageMaker part of it. So this is the whole automation part that I wanted to show in this presentation, to be honest. And I really like to walk you through the whole architecture one day, but with the time limitation that I have, this is all that I could show you guys at the moment. So I will refresh this again. And just to show you a glance of it, there are 448 songs created and about 23 hours long. So what I do is when I'm doing workout, I will just put shuffle mode on, and then I will just go ahead.
1 minute left.
So and I will move into here. So yeah, so that's my presentation for today, and thank you very much. And I'm really glad to be here. And if you'd like to learn more about music analytics as a service, or if you are keen on joining the team, please reach out to me. Go to connect.djayasekara.com. You will have links tagged to my portfolio website, my blog, music analytics, and access to all my social media accounts. And if you have any questions, please free to send me a message on LinkedIn, or you can tweet it even. And before wrapping this off, I wanted to take this moment to thank AWS Community Builders Program and the Japanese AWS user group as well. Thank you very much.
Music's loud and I'm feeling alright. In slow motion, baby, it's just you and I. Yet the burn makes you feel so alive. And we live in the moment.